All right, so we'll pick up this video where the last one left off. So we'll move on to exercise 3b. Here we're trying to multiply two column matrices. And even though these have the same number of entries, it is not possible to compute this product because here we have a 3 by 1 matrix times another 3 by 1 matrix. And again, what we're looking for is that we want the number of columns from that first matrix, which is 1, to match the number of rows from the second matrix, which is 3. And because these don't match, this product would just be undefined. So I'd like for you to just write undefined as the product here. Okay, moving on. I think this would be a good exercise for you to try on your own. So if you'd like to pause the video, you can compute this product. This product will be defined, the product in C. So I think what I would first do is decide what the size of this product should be, and then next compute each of the entries in it. And remember, the location of each entry will tell you which row and which column you want to be multiplying. So in this case, you're multiplying a 3 by 2 matrix times a 2 by 2 matrix. So that product would be well defined, and the resulting size should be a 3 by 2. So we're going to compute this matrix. And again, what we're going to do is we're just going to pick the location for each entry that we want to compute, and then we'll use that location to determine which row and which column to multiply. So I'm first just going to multiply the first row by the first column in order to compute the 1, 1 entry of the product. So I should be multiplying 2, 2 by 0, 2. And if I compute that product, what you should get is 4 here. So the top left entry of the product should be 4. Now, you can compute whichever entry you would like. So, for example, if you wanted to jump down here to the 3, 2 entry, you could. That's the entry that lives in the third row and the second column. But I think it's a little more natural to just compute these entries in the product row by row. So I'm just going to stick to the first row. We'll compute the 1, 2 entry. So that means I should multiply the first row from the left matrix by the second column of the right matrix. So that would be the row 2, 2 times the column 0, 6. And whenever we compute that product, we should get a 12. So what I get as the resulting entry here is a 12. And I'm going to start going a little more quickly through these. What I would like for you to do is, if I go too fast for you on any of these product computations, I want you to just pause the video for a second and then confirm the computation on your own. Because I think that this would be good practice. So if any of these numbers puzzle you, or if I'm going a little too fast for you, I would recommend just pausing the video and trying the computation on your own. Okay. So let's next look at the 2, 1 entry for the product. So that would be here, because it lives in the second row first column. So I should multiply the second row by the first column. So I'm going to multiply the row 7, 1 by the column 0, 2, and the resulting product should be a 2. Okay, and then moving on to the 2, 2 entry, that would be multiplying the second row by the second column. So that would be a 7 times a 0 plus a 1 times a 6, which gives us a 6 altogether. Okay, and then similarly for this last row, if I take the product of the third row in the first column, what I'll get is a 16, and the product of the third row in the second column will give me a 48. So this is the resulting product between those two matrices. Okay, and again, I know that I'm going a little fast here. What I would recommend is just pausing the video if you ever need to. Okay, so next, let's look at some of these products down here. So what we now have is this 2 by 2 matrix times another 2 by 2 matrix. We've already seen that this product will be well defined. It'll be another 2 by 2 matrix. I mainly wanted to point out in this example that it's okay to have negative entries or fractional entries. The procedure is still exactly the same. So for example, if you wanted to compute the top left entry in the product, that would be the entry that lives in the first row and first column. So you should multiply that first row by the first column. And to compute that entry, we would have a 1 times a 3, which is a 3, plus a negative 2 times a negative 2, which is a positive 4. So that's a 3 plus 4, which is 7. And again, if you need to write this on scratch paper, that's totally fine. So if you need a little more scratch work, then that's fine with me. But I think it would be good practice for you to just get used to computing these entries mentally. That'll help you go a little bit faster here. So next, let's look at the 1-2 entry. So that's the first row, second column. We'll multiply the first row by the second column. So that would be a 1 times a 1, which is just 1. And then plus a -2 times 1/2. -2 times 1/2 is a -1. So those entries would cancel out and we would just get a 0 as the top right entry. So the top right entry of this matrix should be a 0. Next, we'll move on to the second row. So if I want to compute the entry in the second row, first column, I'll multiply the second row by the first column. That should give me a -6 altogether. And then if I multiplied the second row by the second column, that should give me a -2 altogether. So this is the resulting product. Oops. Okay. Now, as just a sort of sanity check, I would recommend that you compute this matrix before I do. And you can pause the video if you need to, but this computation should be pretty quick. This is a 1 times a 0, plus a 2 times a 1, plus a 3 times a 0, and altogether that should just give us a 2. So again, because we're multiplying a 1 by 3 times a 3 by 1, the size of the resulting matrix should just be a 1 by 1 matrix, which we'll just identify with scalar numbers. Okay, so next let's look at a slightly more complicated example. So in exercise 3F, we're looking at a 3 by 3 times another 3 by 3. And this product will be well defined. When you multiply two square matrices, the resulting matrix will always be a matrix of the same size. So here, the resulting matrix that we get should be a 3 by 3 matrix. And we're going to compute it using the same methods that we've been using so far. So I'm going to go through these relatively quickly. But if you want some extra practice, you can pause the video now and just go through the computation on your own. But if I wanted to compute the 1-1 entry, I would multiply the first row of the left matrix by the first column of the right matrix. That would give me a -1 plus 9 plus 0, which is a +8 altogether. And again, I'm going to be going through these row by row, so I'll just stick with this first row. Next, we'll do the first row, second column. So if I multiply the first row by the second column, that would give me a -1. And if I multiply the first row by the third column, what I would get is a +15. And then I'll move on to the second row in the product. If I wanted to compute the entries in the second row, then what I would do is I would multiply the second row from the first matrix times the first column in the second matrix. So that would be second row, first column, because I'm computing the entry that lives in the second row, first column. So when I multiply those together, what I should get is a 9 plus a 27 plus a 0. And altogether that should give me a 36. So that entry will be a 36. Thankfully, these next two entries are a little bit easier to compute. So if I want to compute the 2-2 entry of the product, I would multiply that second row by the second column. That should give me a -3 altogether. And then if I multiply the second row by the third column, that would give me a +12. And then lastly, to compute the entries in the third row, I'll be multiplying the third row by each of the columns in the right matrix. So if I want the 3-1 entry, I'll multiply that third row by the first column. That would give me a 15 times 1, which is 15, plus 2 times 9, which is 18, plus 2 times 0, which is 0. So that was a 15 plus an 18, which is a 33. So this entry will be a 33. And then these next two entries, again, will be a little bit easier to compute. So if I take the third row times the second column, that should give me a -2. And then the third row times the third column would be a +6. And now we've computed all of the entries in the product, so we've finished computing the product. Okay. So next, I'll move on to this last one. Now, For this one, if you'd like, just for more practice, you can go ahead and pause the video and compute this. I'm going to take a bit of a shortcut here just for keeping the video time a little bit short. But notice that this is a matrix that we're familiar with already. This is the matrix that I've been calling the identity matrix. It's the diagonal ones matrix. The reason that I'm calling it the identity matrix is because this matrix actually represents the multiplicative identity. What I mean by that is that when you multiply by it, it won't change the matrix that you're multiplying by. So in other words, whenever we multiply this right matrix by the identity matrix will not change the identity of the matrix that lives on the right here. So in other words, I can take a bit of a shortcut when computing this product. The product should just be the matrix that lives on the right, because the left matrix is just the identity matrix. And the identity matrix doesn't change anything when you multiply by it. It's similar to the multiplicative identity that we have with scalars. Whenever you have 1 times 7 in the scalar realm, you're just going to get that right number, which is 7 in this case. The matricial form of this is the diagonal ones matrix, which I'll continue to call the identity matrix. Okay, so you are allowed to use that as a shortcut if you'd like, but it's still okay to use the ordinary matrix multiplication rules to compute this particular product or any of these products. Okay, so lastly, I want to talk about some nice rules for matrix multiplication. So the stuff at the bottom of this page is actually the multiplicative identity that I was just telling you about. So when you multiply by the identity matrix on the left or on the right, you'll just get the other matrix, like we saw above. There are two other important laws that we need to know for matrix multiplication. One is associativity. That says that if you're multiplying 3 matrices in a row, it doesn't matter which way you associate them. So you could first multiply B times C and then multiply that product by A, or you could first multiply these left 2 matrices and then multiply by C. In both of these products, A, B, and C are kept in their original order, so the original order does matter. But it doesn't matter how you associate the two. So for example, in problem 4 here, I am going to decide to first associate these 2 matrices on the right because I know how to multiply those pretty quickly. But it would also be okay to associate the ones on the left instead. So you could first compute the product in the parentheses here and then multiply it by the identity matrix. So it doesn't really matter which order you choose here. And then the last law for matrix multiplication is just that distributivity works in the same way that you would expect it to. If you're multiplying A times B plus C, then A will distribute from the left, so you'll get A times B plus A times C. Notice that A is still on the left in both of those products. If you distribute a matrix from the right, like C times A plus B from the right, then C will remain on the right in both of those products. But you can still distribute in the ordinary way. Okay, so we'll put these rules together to compute this matrix in problem 4. So here we're multiplying a matrix by the identity matrix, so we know that the resulting matrix on the inside of the parentheses is just going to be this left matrix, which is a 1, 1, 1, 2. And now we'll compute this product. So this is a 2 by 2 times another 2 by 2, so the resulting product should be a 2 by 2 matrix. And we'll compute its entries individually. So if I want the 1, 2 entry, or sorry, the 1, 1 entry, I would take the product of the first row and the first column. That should be a 0. The product of the first row second column is also a 0. The product of the second row first column is going to be an 8. And the product of the second row and second column is going to be a 14. And I don't expect you to be going through the computation that quickly, but I would like for you to start being able to compute those mentally by just slowing it down and looking at the appropriate row and the appropriate column and multiplying those together. So if you need to backtrack a little bit and compute that on your own, then you're welcome to. Okay. And that's actually the end of the matrix multiplication section. What we're going to do next is we're going to figure out how to find the inverse of a matrix, and that will be the topic in the next video.